Hi, I'm Andy and welcome to my walkthrough of the 2020 Sans Holiday hack. In previous videos we've been undoing the damage that Jack Frost caused. The next objective is to gain access to Santa's office, which should be pretty easy as we can now take on his form via the painting, but the challenge specifically requires us to bypass the fingerprint sensor. We'll probably need to fiddle with the HTML and JavaScript within the elevator system, so let's stop off to see Rib in the dining room. He has a JavaScript coding challenge which would be a good warm-up exercise. The game involves using JavaScript to control an elf character to pick up lollipops and make it to the finish point whilst avoiding pitfalls and getting attacked by munchkins. Pits can be opened up by pulling levers and munchkins pacified, but both require some additional coding to submit a particular answer. And to add to the challenge, the levels must be completed in a limited number of lines and statements. Level 1 starts fairly easy. The elf just needs to move 10 spaces left to collect the lollipop, and then up 10 spaces to make it to the end of the level. In Level 2, the elf's path is blocked by a trap which will bounce it off the screen. The lever needs to be pulled in order to disable the trap, and the objective details states that we must submit a value to the lever which is 2 greater than the value provided from it. We just need to make sure that the elf character stops in the right place and submits the right value before moving on. Level 3 looks trivial to start with, although it must be completed in no more than 4 lines of code. Thankfully, there's a function which directs an elf to walk towards a certain object in just a single statement. The pathfinding used by this function is very basic, but it works just fine in this case. Level 4 requires a lot of movement, but again has a limit of 7 lines of code. The movement is repetitive, however. Move left, up, left again, down, and repeat several times. Note also that it's possible to specify a larger value than an elf can move, and the elf will stop when it hits an object. For example, the first move to go left could be any value. The elf will always stop when it hits the barrel. That means we can define a pattern of left 3, up 11, left 2, down 11, and repeat the whole lot 3 times to complete the level, even though not all of the commands end up being executed fully. Things get more tricky in Level 5, where there's a limit of 10 lines of code and 5 elf statements. A single request to move the munchkin is enough to collect both lollipops en route thanks to the way pathfinding works in this game. The objective says that to pacify the munchkin, we'll have to tell it only the numbers from the array that it provides. JavaScript has a filter method on arrays which can be used for this purpose. The argument provided to it is a function which is then called once for each item, and only those items where the function returns true will then be included in the resulting array. JavaScript already has such a function, number.isInteger, so we can just specify this rather than writing our own. We get 2 methods to complete level 6, either by pacifying the munchkin, or by pulling the lever and causing the munchkin to fall in the pit. Either way requires navigating the lower and right portions of the map first, and the level has a limit of 15 lines of code and 7 elf statements. The lollipops are arranged in ascending order, so we can use a loop with a variable x incrementing 1 each time to go to each in turn using just a single elf statement. If we're taking the lever route, we're tasked with adding an element containing Munchkin's rule to the start of an array provided by the lever. JavaScript has a handy function called unshift that does exactly this. With the lever pulled, the trap opens and the munchkin falls in. We're then left with just enough elf statements to navigate to the end. The munchkin route for level 6 requires searching a JSON object and identifying the key name that's associated with the value lollipop. A list of all the keys in a JSON object can be retrieved with the object.keys method. These can then be iterated over in a loop, searching for the value of lollipop, and then recording the name of the key once found. Completing level 6 is enough to pick up the achievement for this game, but there's a couple more bonus levels. In level 7, the elf needs to spiral out from the centre. Each step, the length of the movement increases by 1, so we can use a loop with an incrementing counter to handle this movement. The direction of movement changes each time though, and this can be accounted for by applying the modulo operator to the incrementing value. This divides the value by 4, as we have 4 directions, and returns the remainder. Depending on the remainder, the elf needs to move in a different direction. There's a series of pits along the way, which can be covered by pulling the lever, which requires passing the index number of the lever. This index is always 1 less than the number of steps the elf has just walked. After completing the spiral, there's still a munchkin to contend with, who wants to be provided with the name of a function which will iterate over all elements in a 2D array and add up all the numbers. We can define our own function which takes an input and then loops over each element. Each of these elements is an array itself, so another loop is required to iterate through the individual items. We can test each to see if it's a number, and if so, add it to a running total, which is then returned. Level 8 also has a repetitive motion, where each row's length increases by 2, so we'll need a loop where the iterator value increases by 2, not 1 each time. The direction changes from left to right, so we can add a variable to keep track of this and alternate between them each time. The levers en route require a value to be submitted which is the total of all previous lever values, so this can be achieved with another variable to keep track. The munchkin on the final row wants a function which can return the key name where the value lollipop can be found in a 2D array. This is a combination of the munchkins from the previous 2 levels, so it's fairly easy to combine the code from the 2 to satisfy this requirement. With the game now fully complete, we get an extra achievement and can pick up some extra hints from Rib before moving on to the main objective. Although our task is to bypass the elevator's fingerprint sensor and access the office in our normal form, it's worth trying this in Santa form to see what can be learnt about the system's operation under normal circumstances. After jumping through the painting again, we still need to reconfigure the sparkle stream with the other objects that we recently picked up. This is made pretty easy thanks to the portal candies obtained from the vending machine. With the panel now fully powered up, pressing the button for level 3 exposes a fingerprint reader, and pressing this operates the elevator. Within Santa's office we meet Tinsel, who tells us about something very wrong with the Naughty Nice List blockchain. That's our objective for part 11, so for now let's jump back in the elevator and see how that fingerprint sensor is working. We can right-click on the fingerprint reader and choose Inspect to locate the exact HTML code which represents it. It's pretty sparse, however there's a JavaScript event attached to it. Clicking here navigates to the relevant line of code in app.js. There appears to be a symbol test of hasToken bSanta, which, if fails, prevents the elevator from moving. There's also an AJAX call, which includes sending getParams.id, which appears to be the unique user ID number for my account. After clicking on the button to send this request, through the Network tab we can see it returns with the success code 200. The only other thing of note here is that the referrer URL contains a list of items collected, and that bSanta token. It looks fairly trivial to remove that test for the bSanta token to bypass the fingerprint reader. Let's go jump back through the painting to return to our normal form and give it a try. Back in the elevator, we can repeat the same process as before, inspecting the fingerprint reader element, navigating to the JavaScript code, and this time commenting out the test for bSanta. Now just to click on the fingerprint reader and nothing happens. Further inspection shows that the event trigger is now changed to VM9 app.js, and in this version the bSanta test is still there and cannot be modified. Now, I'm not certain of what's happening here, but I suspect Chrome is doing some sort of code compile when the page loads, and so it's not possible to edit code on the fly. Please drop me a note in the comments below if you can describe this behaviour better than I can. One option around this would be to proxy web traffic via something like Burp Suite and manually tamper with the app.js resource before it gets returned to the browser. Chrome offers another option in the form of source overrides. This needs a local folder to be defined to store the overrides, but once set, allows the modification made to this file to be saved as an override. Note how once complete, the asterisk next to the file name is gone, suggesting that changes have been saved, and a purple dot appears to signify that this file is subject to local override. Chrome also shows a warning in the Network tab to indicate that some resources transferred over the network may be overridden by local files. With the override now set, we just need to hit F5 to refresh the page and try again. Although, note it's necessary to hit F12 and just flash up the DevTools on each use to activate the override. Presumably, this is a security feature to prevent attackers or malware silently installing local overrides and requiring a developer to intentionally do something to make overrides effective. Once in Santa's office, we get acknowledgement of completing the objective. That's all for this video, but leave a comment if you have any questions or if you used a different method for solving any of these puzzles. We'll pick up the story again in part 11, where we'll be hacking random number generators and investigating blockchain hash collisions. Feel free to take a slight detour on your way and check out some of my other cybersecurity videos, otherwise I'll see you there.